Welcome to Spring LIB.
For the given reaction, we have 3 Ag2S. This is solid. Plus 2 aluminum solid in equilibrium with 6 Ag solid, 3S2 minus, 2 aluminum 3 plus. For part A, we're asked to calculate delta G naught, K, and E naught. So let's start out by calculating the delta G naught value. Delta G naught is equal to the sum of the delta G naught formation for the products minus the sum of the delta G naught formation of the reactants. This is equal to 6 delta G naught formation of Ag solid plus 3 delta G naught of S2 minus, add 2 delta G naught of aluminum 3 plus minus delta G naught 3 delta G naught of Ag2S plus 2 delta G naught of aluminum solid. We can look up values from Appendix 4, or there's some given in the question here. So this would be 6 delta G naught formation of silver is 0 plus 3. And for S2 minus, this would be 86 kilojoules per mole. And then for aluminum 3 plus, it's negative 480 kilojoules per mole minus 3, and then for Ag2S is minus 40 kilojoules per mole plus 2, and for aluminum this would be 0. And working out our delta G naught here, we find that this is equal to negative 582 kilojoules per mole. Now let's calculate the E naught here. The delta G naught is equal to minus NF E naught cell. Delta G naught is negative 582 kilojoules per mole. N is the moles of electrons that get transferred. So this is equal to minus 6 moles of electrons. F is a Faraday constant. This would be equal to 96.5 kilojoules per volt, and this would be E naught cell here. Working this out, we find that the E naught cell here works out to 1 volt. And then we can calculate the equilibrium constant using the Nernst equation. The log of KEQ is equal to NF E naught cell over 2.303 RT. This is equal to 6 moles for electrons. F is 96,500 joules per volt. E naught cell is 1 volt, which we just calculated, 2.303, 8.314 joules per mole Kelvin. Temperature is 298 Kelvin, and this would be equal to 102 KEQ is equal to 10 to the 102, and that would be our equilibrium constant. For part B, we are asked to calculate the value of standard reduction potential for the following reduction half reaction. So we have 2E minus, add Ag2S, going to 2 Ag solid, and S2 minus aqueous. So E naught reduction here is our unknown, and the other half reaction here will be the oxidation of aluminum, and this would be aluminum going to aluminum 3 plus and 3 electrons. The E naught oxidation here would be 1.66 volts. So the E naught cell here is equal to the E naught reduction plus the E naught oxidation. E naught cell is 1 volt, E naught reduction, and this is plus 1.66 volts. So this would work out to E naught reduction here is minus 0.66 volts for the half reaction. So if we go back up here, the E naught reduction for Ag2S to Ag and S2 minus would be minus 0.66 volts.